And welcome back, everybody. Today is day 19 of doing the daily Leetcode problem. Today looks like we've got an easy problem. The problem is 2,200. Find all k distant indices in an array. The description says we're given an array called nums and two integers key and k. A k distant index is an index I of nums for which there exists at least one index j such that I minus j, the absolute value of that, is less than or equal to k, and nums j equals key. Return a list of all k distant indices sorted in increasing order. So k distant index is an index such that at least one index I minus j is less than or equal to k, and nums of j equals key. Return a list of all k distant indices. So our key is 9. So we're going to look for 9, right? K equals 1. This means it has to be in the proximity of one index, right? The output is 1, 2, 3, 4, 5, 6. Why is that? It's an index. 0, 1. Nums 2 equals key. Sure, because that's 9. That's our key. And nums 5 equals key? Huh? 0, 1, 2, 3, 4. Oh, that makes sense. Sure, yeah. So it would be 0, 1. I guess 2 counts. 2, 3, 4, 5, 6. Because there's 2 keys. So there can be multiple keys, sure. For this, key equals 2, so it's just going to be, okay, all of them. Sure. Key is an integer, so we just have to find key and find the index of it. Okay. I think the only tricky part of this problem is going to be, since there can be multiple keys, we just have to realize that. Might as well get the hint. For every occurrence of key in nums, find all distances within k. So I guess we can just start writing code and then debugging as we go. So I'm guessing we're going to be iterating through the nums, right? We're going to have a array which contains all of the indices that are within the range, right? And then if we come upon, if nums of I is our key, then we want to add all the indices within the proximity, right? So we're going to go through all these. Once we find 9, once we find 9, we want to add all of the we want to add all of the indices within the range to our result if and only if the number or the indices are not already in the array, right? So we're currently at index 0, 1, 2. So while or maybe we can have a helper function here. Add indices to add indices in range self nums and I guess we need k as well. And we want to return a... Oh, do we want result as well? Yeah, we definitely do. We also want result, which is this, and we want to return a list. Alright. So if nums equals key, we want to for I in range, we want to, if k is 1, we're currently at index 2. I guess we'd also want the current index, right? I. For I in range, if current in, because what I'm worried about right now is if current index is like 2, but k is like 10 or whatever, and it goes past this start of the array, I'm wondering if there will be an error there or if Python handles that internally or something. But just in case, I want to like handle that at the top. So if current index, so 2 minus k, so 1 minus k is less than 0, then current index equals 0. If current index plus k is greater than the length of nums, then current index equals length of nums minus 1. And then for I in range, no, that's not right. I did that all wrong. start end equals current index minus k current index plus k. I think that's right, and then we want start to do this, to be this, and end to be this. I like it, I like it. So for I range, start and end plus 1, because end's exclusive in range. So this, if I not in result dot append I, think that looks good. And then does this automatically, I think this automatically updates the results, I believe. Nums equals k, add indices in range, but we need to do self dot, and then nums k I result. And then let's just see what this does. Okay. Wasn't that bad though? Sure. Passed the first case. I like it, I like it. Second case, it added an extra 0, 1, 2, 3, 4. Why? Why did it do that? Is it the plus 1 that's fucking me up? But then that happens. I think it's something... maybe I get rid of this. K equals 2, k equals 2. Okay, let's just see what this is doing. So if nums I equals key, this equals key, this is, so the only place where it would be a problem is since k equals 2, it would start here. So 0, 1, 2, 3. Current index equals 3. So right here, end would be 3 plus 2, which is 5. We can actually just do this with that, since this is literally the definitions. If start is less than 0, if end is greater than length of nums. If end is greater than length of nums, so I think this is, I think we missed this. Does this work now? Perfect. And the reason why this is because this, where index 3 is the place where the problem occurs, where since k equals 2, it needs to go 2 places outside. But there is no index outside of the last element, obviously. So we were checking if end is greater than length of nums. End would be equal to our current index, which is 3, plus k, which is 2, so that would be 5. But we are checking if it was greater than, but it's actually equal to, because the length is 5, and then our end is 5. But we want it to be minus 1, because obviously in that case there would be no last element. Let's see if this works, hopefully. Please. It's slow. That's not good. Is this solution too slow? Oh no. It's an easy problem, mate. What is this? It's because it's a nested for loop. That's the reason. Oh, I don't like it. Ugh. If maybe there's a shortcut we can do. If so this is one of the harder easy problems I've faced. Hint 2. Use a hash table to remove duplicate indices. For each value in the nums array that equals key, store its index in a list. Key indices equals this, result equals this, nums equals key, then key indices dot append I. Just get rid of this. Probably don't need a helper problem for this, or a helper function for this problem. And then let's print key indices. For each one of your save, find the absolute value of each possible index. If this value is less than or equal to k, and this value. Find the absolute value of each possible index in your saved index. Okay, so once we have our key indices, and where our keys are in the list, then we want to iterate through our key indices. I think I'm going to need to look at a solution. I think once I see the solution, it's going to be super easy for me, but index and equals link nodes for I in range n, for j in range n. It's really just a nested for loop. Does this really work? So you're just saying if numbers equals key, and then you have 1, so you get to 9, and then you have j going through each one. Wow. Does this really work? And is this the solution? Let's see what the fastest. Okay, result. Okay, so we have our result array. Unjudged minimum index. What does that even mean? Okay, so this is an O of n solution, yeah? So we have a result array. This is just this comment is just confusing me. N equals length of the numbers, length of the array. Iterate through the nums array. If we come across the key, then we want to L is max between R and J minus K. So which one is greater? R starts out as 0, or J minus K? J minus K is the start, right? Okay, that makes sense. That makes sense because this is just making sure it's within the boundary. Sure. R equals min the length minus 1, so the end, or J plus K plus 1. Yeah, this is just, maybe we could just, I think it would be easy to understand with this. J plus K, so this is, so find the start of the range, find end of range, making sure it doesn't go out. And then add why? My question is, why does this not contain duplicate? Okay, what did I do wrong? What? Is this what I did wrong? Wait, is this actually what I did wrong? Why does that work? What? Huh? Oh. Because in this you're actually updating the variable, but in this you're not. Ah, because R keeps track of the outer. That is so clever. I feel like this should be a medium problem, or maybe I'm just not thinking straight today. And it automatically is in increasing order. Find end of range and now we just need to make it look pretty. We come across a key. Find start of range, find end of range. I think we need better variable names here. Right boundary. Left boundary equals I think we can change k with radius. Because you really can think of it as a radius. Length minus 1 r right boundary. Right boundary equals it seems like such a simple solution, but it's not at all. Result. Think it's all updated. Making sure. Okay. So hopefully these variable names help you better understand what the solution is actually trying to do. We're iterating through the nums array. If we come across the key, then we find the ranges, we find the outer ranges or the outer values for where we're going to be adding the indices to the result array. Once we find those outer boundaries, we iterate from start to end, from left to right, and then we add those indices to the result array. And then the beautiful thing about this solution is that after you add it to the array, you actually start from where you left off, which makes it go a lot faster. So now you actually start, since k equals 1, you're actually adding these 3 first, and then you actually start at 3, and then you go to 9, you realize, okay, 9, 5. But the outer boundaries are always going to not overlap with this solution. And that was kind of the problem I was having at the start before I found the solution. So, okay. Good to learn these things. See you next time.